Hello everybody and welcome back. We're going to take a look at the 2000 Euclid paper in this video. We're up to question number 3. Now we can see question 3 is broken into 2 parts, and if we give them a quick read through or just a glance, they don't really have a whole lot to do with one another, and that's to be expected of these earlier questions. They're sort of a bunch of tiny little questions smashed together to make questions 2, 3, 4, that sort of stuff. Questions 8, 9, and 10 later on we'll see they have multiple parts, but they're all related to one another. Okay, so 3A, it's a light bulb question, so we don't need to do a whole lot of writing. We just need a final answer and maybe a little bit of justification if we want part marks in case we screw up. A circle with diameter AB as shown, so that's negative 2, 0, 8, 0. So immediately I can tell what the length of the diameter is. It's going to be 8 minus negative 2, that's going to be 10. So this circle intersects the positive y-axis at the point D, 0D. Determine little d. Okay, so it's going to be a positive value. Got to make sure of that. And I can see sort of 2 ways to go about doing this question. The first way, very common, very natural way of doing things, we have a diameter, we know its endpoints, we can figure out the midpoint. That's going to be the center of the circle. And as I already remarked, we can easily tell the diameter is going to be 10. Once you have the center of the circle and you know the radius, half the diameter, so in this case 5, we can set up an equation for the circle. And we can take that equation, intersect it with the y-axis, which is the line x equals 0. And we'll get 2 points of intersection. We just take the one that lies in the positive, the upper half of the plane. Okay? That's the way I would expect most people to do this question. But there is a slightly faster way, and it relates to the fact that the picture is symmetric about the x-axis, and it has to do with a little bit of circle geometry. It's the power of a point theorem. Is it the point, or is it the cross ratio? No, it's the cross ratio, sorry. No, power. Anyways, you'll see the technique. I do not remember the name of it off the top of my head because I don't really memorize circle geometry proof names, circle geometry result names. But it's a much shorter way of doing it, and it's still going to get us the same answer. And it's for those of you out there who are being a little clever, who have seen circle geometry before. Now, if you haven't seen anything like this before, that's okay. Maybe this will spur you to learn something. If not, I'm going to go through the other figuring out the circle equation method. Because many of you have likely done it that way. But both methods are equally valid. The shorter one is obviously preferred if you are trying to just blaze through the early questions and get to the much more difficult late questions with enough time to adequately solve them. Okay? Remember, we only have about 2.5 hours for this contest, so you want to get the early ones done quick. So I'll show you how to do the short way of doing this question, and then we're going to go through the longer way. That's a beautiful circle right there. That's majestic. All right, so we have 0D, and we have 8, 0, and we have 0, negative 2. Now, I was being a little silly there. This is actually a terrible picture. I hate this circle. I'd redraw it, but I don't really need it a whole lot. So, some of the things we can note, this is a circle. More importantly, it is symmetric about the x-axis. Okay? So the top half looks like a reflection of the bottom half and vice versa. So that means that the other intersection point here is going to be 0, negative d. This is by symmetry, and I would write that out. By symmetry, we can tell this other point is 0d. Okay? So what does that tell us? Well, we can start figuring out lengths of this axis, these lines right here. So this is the diameter. And we can tell going from the point 0, 0 over to this other point here, I believe it was called A, it's a length of 2. going from the origin to point B is a length of 8, and these two lengths are d's. Okay? I believe it's the cross ratio, although technically it might also be called power of the point. I think this result's only called power of the point if the point lies outside the line, but it's been a while since I did circle geometry. So let's draw a little better circle. I think that's a better circle. If we have any two lines here, and they intersect in a common point, and one line in one chord of the circle, possibly the diameter is AB and the other is CD, and this midpoint here is P, well, not midpoint, but the point of intersection here is P, then AP times PB is the same as CP times PD. Okay? That's what this result tells us. So if we were to call this brand new point down here, we were to call him C, well, this one over here is B, this is A, and this is D up here, then the origin is our point P. It's the point intersection of the lines CD and AB, which are chords of the circle. And we know that AP is 2 times 8 should be D times D. So 16 is D squared, and therefore D is equal to 4. Okay, that's our short method. And that'll work, and that'll give us an answer of D is equal to 4. Now let's go through the long method. We're going to actually figure out the equation of the circle and intersect it with the y-axis. See if we can draw a better copy of this picture. That's better. Definitely better. So we have 0D, we have 8, 0, and we have negative 2, 0. Okay? So the midpoint of a diameter is the center of a circle. So if we want to take the midpoint, we add the x-coordinates and divide by 2, and we add the y-coordinates and divide by 2. And that's going to be negative 2 plus 8 is 6, divided by 2, so that's 3, 0 is the center of the circle. 3, 0. Okay? So the radius, pretty easy to see since these two fellows lie on the x-axis. It's going to be 8 minus 3 is equal to 5. And we can check that the distance between 3 and negative 2, that's also 5. So the equation for this circle is, well, what's the general equation? If you're centered at HK and your radius is R, then this is what your equation is going to look like. Well, we know what H and K are. They're 3 and 0, respectively. X minus 3 squared plus y minus 0 squared. And we know what R is. It's 5. So our equation, if we simplify it a little bit, is x minus 3 squared plus y squared equals 25. That is the equation of the circle. Now, we want to figure out what the points of intersection between that and the y-axis are. Okay? So we'll intersect with the y-axis. Which is the line x is equal to 0. Okay. So we'll plug in the point 0d, so 0 minus 3 squared plus d squared is equal to 25. Well, that's 3 squared plus d squared is equal to 25. So that's 9 plus d squared is equal to 25, and hopefully many of you are familiar with the 3, 4, 5 triangle. You should know at this point 3 squared, 5 squared, that's going to be 4 squared, so d should be 4. But if not, that's okay. We rearrange this equation. 25 minus 9, that's 16. And wouldn't you know, we get to the same result we had with our shorter method. D is going to be plus or minus 4 in this case, but we want D to be the positive value. So D is equal to 4. Now it's a light bulb question, so one method really isn't preferred over the other, but one is shorter if you're familiar with the cross ratio. Okay, so that's part A. We still have a part B we have to do, and this one is written. So we're going to need to explain ourselves, justify our final answer. Okay. A square, PQRS, with side length x, is subdivided into 4 triangular regions as shown. So we have this big one here that almost looks equilateral, but you can tell it isn't. And it's got triangle A, triangle B, and triangle C. So we're subdivided so that the area of triangle A plus the area of triangle B is equal to the area of the bigger triangle C. And we sort of ignore this white triangle here. If length PT is 3 and length RU is 5, determine the value of x, which is the side length of our square. Okay, so the first thing we need to do, draw the picture. We draw the picture, we start filling in whatever values we can. Can we figure out the value of TS? Or can we figure it out in terms of x? Things like that. We're talking about areas, so do we just need to start putting in coordinates? Do we need to start using particular formulas to start calculating the area? These are the things we do once we have our picture that we can doodle on and start coming up with ways to try and solve this question. So, here is our square. Much easier to draw squares, although somehow I'll screw it up. Nope, we're fine. X, and I think it was P. Yeah, it was P up there because here's T. Q, that'll be R, S, and they called this point U. We were told this is 3, this is 5. This one is A. This one is B. And this one is C. Okay. So we can see pretty quickly that length PT plus length TS, which is an unknown value, is the length of PS. So that's 3 plus TS is equal to x. Well, we could just say that length TS is x minus 3. Okay. By the exact same reasoning, while I have the pen out, we get x minus 5 for the length SU. US is x minus 5. Okay. Now we have 3 triangles, and most of their sides are figured out. Could we figure out this other length here? Or is there a way to do it with the information we already have? Okay. Suppose I wanted to figure out the length QT. How might I do it? I have a 3, I have an x, but I don't have a whole lot else to go on except the fact these are squares. Or sorry, this is a square. Not these are squares. So all these angles are right angles. Notice A, B, and C are all right angled. So if I wanted to, I could use the Pythagorean Theorem to figure out QT and QU and TU, just get a little more information on these triangles. But I don't need to solve the question. Right? We're talking about the areas, and we know the area of A plus the area of B is equal to the area of C. Well, since they're right angles, we have bases and heights given to us by the side lengths. So the area of A, it's 1/2 base times height. The base can be 3, and the height can be x. So that's 3/2 x. The area of B can be 1/2 base times height. We can say the base might be x and the height is 5. 5/2 of x is the area of B. Now for the interesting one, area of C. 1/2, we'll say the base is x minus 3, and the height is x minus 5. So we're going to get 1/2 of, using FOIL, firsts, outsides, insides, lasts. We're going to get x squared minus 8x plus 15. Okay? So why did we look at these areas? Well, recall that the question told us something about their areas. And that's why we're shooting for the areas of A, B, and C. That's why we said, well, how much of these triangles do we need to figure out to get the areas? Because we have a relationship between the areas. And I'm betting we can use this relationship to solve and figure out what the value of x is. Okay? So now we have A, B, and C, their areas expressed completely in terms of x's. And since we have a relationship amongst them, we can set up an equation. A plus B equals C. So we're going to get 3/2 x plus 5/2 x is equal to 1/2 x squared minus 8x plus 15. Okay. Now I can combine A and B, add these two together because it's still x divided by 2, so the 3 and the 5 are going to add up. And we're going to get 8 over 2x. Okay. Now, what I could do is divide 8 by 2 and get 4. But instead what I'm going to do is I'm going to leave a half out there and just have an 8x. Why? Because now that I have a half here and a half here, I can start bringing these two together. So we want a 0 on this side, so we bring everything else over to the other side. Minus a half 8x, and now that they both have a half out in front, we can keep that half out front and bring everything else in together in the same bracket. X squared minus 16x plus 15. Now you can keep manipulating it with the half there, but you don't need to. Now that we have this 0 here, if we multiply both sides by 2, we're still going to get a 0. But now we get rid of that pesky half, and we have a simple quadratic formula. Quadratic equation. You could have expanded this out with the 1/2, and you get 1/2 x minus 8x plus 15/2. And you could apply the quadratic formula to that quadratic equation. Either way, it's perfectly fine. So, we can either use the quadratic formula, or we can ask ourselves, what two numbers multiply to 15 and add to negative 16? So think about that for a second. What two numbers multiply to 15 and add to negative 16? Can it even be done? Okay. We're going to go through the quadratic formula in a moment, but it's good practice because often when you have something like this, especially if these numbers are off by 1, you can very easily get some very nice values. X minus 1 and x minus 15 are going to do. So our roots should be 1 or 15. Now suppose we didn't know that. We could use the quadratic formula. So we'll check with the quadratic formula. X is negative b plus or minus square root of b squared minus 4ac. So negative b, that's going to be 16 plus or minus square root of b squared. So that's negative 16 squared. That's going to be 256. Get your calculator out if you need to. That's okay. These are allowed. Minus 4ac. 4ac, so that's going to be minus 4 times 15, so that's minus 60, all over 2a, so 2 right there. So we're going to get 16 over 2, that's 8, plus or minus square root of 196 over, is it 196? 256 minus 60. Yeah, all over 2. And this 196 happens to be 14 squared. So 14 over 2, so that's 8 plus or minus 7, 1 or 15. Either way you did it, that's fine, but trying to factor a quadratic like this is very good practice, and it can actually be much faster than methodically plugging in the quadratic formula. Both methods have their virtue. Trying to look at an equation and factor it, like saying x squared minus 6x plus 5, well, that's obviously got to go to negative 5 and negative 1. So our roots are going to be 1 and 5. That can work, and that can be very, very fast, but sometimes it just doesn't work. The quadratic formula, while a little longer and sometimes a little harder to simplify, always gives you the right answer. Always, always, always. So you have to juggle, you have to try these contests enough, and you just sort of get a sense of when should I do this, when should I do this. And even today, sometimes I still pick the wrong one to try and do. I'll stare at an equation for 5 minutes before I realize I'm pretty sure that this doesn't have nice roots for me to work out. Okay? So you really have to, it's an experience thing, you have to try both methods and see what you're comfortable with. Okay? And I also noticed I do have a typo here, quadratic, not quadratic. Alright, so these are our values of x. Okay, so it looks like we have two potential values of x. We can have a square of side length 1 or side length 15, right? Right? We worked out what our x's could be, 1 or 15. And how does this square with our square? Side length of 1, 1, and then 3 and 5. Oh dear. PT is equal to 3. RU is equal to 5. These are parts of the sides. These aren't much bigger than the sides, so we can see x has got to be bigger than or equal to 3 or 5. So we can't have x equals 1. We can't have a square of side length 1 and then a segment of one of its sides has length 3. That doesn't make any sense. X equals 15 is the only one of these two answers that is big enough to actually have a side that splits into 3 and 12 and 5 and 10. Okay? So x equals 15, and that's going to be our final answer, and we were able to show it. So what did we do? We realized we have a relationship with the areas. We're asked for a single variable x, so likely what should happen is we should be able to get these individual areas in terms of x, plug them into this equation, and then we have a relationship we can solve for that single value of x. It turns out in this case it was quadratic. We applied the quadratic formula, and we were able to come up with two values of x, and we just had to stop, take a step back, assess the situation, and actually see, well, only one of these values of x actually makes sense with the question. Okay? So that's B in question number 3, and we're going to take a look at question number 4 in the next video. So I'll see you guys then.